So interest is one of the very first economic concepts you'll learn about. And let's just figure out how you derive formulas for interest and use some basic examples to help you understand the concepts. So usually you think of interest in terms of banks. If you give $1,000 to the bank, then they're going to hold that money, but over a certain amount of time, like let's say 1 year, every year they're going to give you some more money to add to that, so that after a couple of years when you get back your money it's going to be more than 1,000. So let's give a simple example. Let's say you have an interest value 50%. So the bank tells you, okay, our interest rate is 50% and we're going to compound it annually, which means that your period, like we said, is 1 year. Every year they're going to do this. They're going to take your money, multiply it by 50%, which gives you $500, and they're going to add that to what you had. So then now you have $1,500 at the end of 1 year. And it happens in a split second. So then at the close of this year, they're going to do this once. Now if they say, let's say you go to the next year, it's still 50%. Well, they're going to take 50% of this, which is $750, and then they're going to give you everything. So now you're going to have $2,250 in 2 years. And let's say they do it one more time for the third year. Well, you can see where this is going. By the end of 3 years, you'll have $3,375. Now that's a ridiculously huge gain from measly $1,000 3 years ago. So obviously banks will never have a 50% interest rate. It's going to be something less than 10 to be manageable for individuals. So let's now talk about more abstractly so we can reach some kind of formula we can use for any given situation. So let's look at the variables we used in that example. You have your initial $1,000. Well, that's going to be P, which is your principal. That's just what they call the pot you put down right at the beginning. Then you have your interest rate. Let's call that I. And that's something the bank sets. And if you're solving problems in economics, this will be a variable, a constant that the problem gives you. So in our case, it was 50%, but it should probably be something around 6%. You have the period over which you do that mathematical calculation, the period over which you compound your investment. And this is going to be some measure of time. In our case, it was 1 year, but then a bank can compound quarterly, which is 4 times a year, and it can compound monthly, which is 12 times a year. And this value would just become, let's say you want to find out in a year how much money you have. Well, N would be 1 if you compound annually, it'd be 4 if you compound quarterly, and 12 if you compound monthly. And then you'll probably have F, which is just what you want to know. So in our case, and in most cases, you want to put in P with a given interest, and you want to know after a certain period how much money you have, how much money you can take out of the bank. So let's look at how we can derive a formula from this. You start with P. In our case, remember, it was $1,000. And then after one period, so keep in our heads that N equals 1 at this point. What we did was we added to that $500, and $500 was created by taking the initial and multiplying it by the interest rate, okay, which in our case was 50%. Now let's write this a little more simply. Now notice here that it's P times the quantity 1 plus I. You want to think of 1 as what you had originally added to the little amount of value accrued through investment. So this is after one time. What if you do it again the second year? And see that we're thinking abstractly now, so try to hold both the idea of $1,000 with these variables. So you have this much in the bank because you didn't take it out. So you're going to do the same process here of taking the original and adding to it some kind of interest, but you're going to use this and substitute with p, because now this is your starting point. So if we put this here, and now we add to that this. So we're going to add the original times I. So you see how this lines up with this, and this lines up with this. It's the same exact mathematical concept here. But after on the second period of when you compound the money, this is what happens. Now if you rearrange this, interestingly enough, you get 1 plus I squared. And you can guess that after 3 years, you'll have p 1 plus I to the third. So we can generalize at this point. Depending on what n is, you're going to get this to that power. So we can now write our very, very useful equation, which is you give a principal, you compound it over a given period, and that's going to be the money you can take out of the bank.